Hey guys, it's Force here to force some physics into your brain, and today we're going to be talking about resistant forces of motion. So if you have a car here, let me just hop right on in. You might be wondering, how come the car starts to slow down when you take your foot off of the accelerator? Or why, when you run out of gas, it's so hard to push the car from start just by pushing it by yourself? Well, you see, when you move in a car, your car has a direction of motion. The ground is going to exert a force on this direction of motion, and this force is going to try to oppose this change in direction of motion that you're trying to inflict with the car. The force that the ground exerts upon the car is known as friction. So let's take it on over to the chalkboard. So friction is defined by normal force times the coefficient of friction. This coefficient of friction is going to change depending on the surface that you're traveling on. The rougher the surface, the more friction that you're going to have. And the normal force, if you remember, is the opposite of the mass times the force of acceleration. So this is going to be the force that the ground is exerting back up on the car. So the heavier that you are, the more the normal force is going to be, and hence the more friction there's going to be. Mass times acceleration, remember, is a force. So the normal force is in fact a force. The heavier your object, the more friction acts against your change in the motion. But the ground isn't the only thing that can impact a resistant change in motion on an object. So if we have a rocket ship here, let me hop on in again. The rocket ship is going to be moving up. Of course, there's going to be a resistant motion or a resistant force that's acting on your change of motion. Instead of friction, this one is going to be called drag. And drag works against the motion that you're trying to inflict with the rocket ship. Let's take it back to the chalkboard. So drag's a lot more complicated than friction. There's a lot more variables that you have to worry about. But drag is defined by 1/2 times the drag coefficient times the density times the surface area times the velocity squared. Quite a mouthful. The drag coefficient changes, just the coefficient of friction. But instead of this being due to the surface, this is actually due on the object that you're trying to move through the air. So it's going to depend on how flat the front face of the object is that's going right into your direction of motion. The rocket ship has a cone with a point on it, so that way this drag coefficient isn't as high as it would be if it was a flat front. The density depends on how dense the medium is that you're trying to move through. In this case, the air, but the medium could be water if you're a submarine traveling through, but for the most part, it's just the air. Surface area in the equation depends on the area of the cross-section of the rocket that faces the wind. So this is going to be the fattest part of the rocket that's trying to make it through the wind. And the velocity is how fast your rocket is moving through the air. So as you see, there's a lot more variables that you have to worry about when you're going through with drag as opposed to just friction, where it's the normal force, which is basically the mass and the acceleration, and the coefficient of friction. But anyway, those are the two resistant forces that mainly pop up in our daily lives. Hopefully they don't drag you too much down. See you next time.